I'm here to present building conceptual design and our enhancement program for building group in CPH. This is my outline of my presentation. So my first objective is to initiate a uniform and common understanding on the work nature of building conceptual design. Second is to highlight CPH participation in building design of Chiyoda and showcase our current projects and previous work achievements. Lastly is to explore areas to improve for CPH in the field of building conceptual design. So, as introduction, let me first define building design. Building design is the activity of providing and connecting all relevant information necessary for the construction, renovation, and modification of buildings that satisfy all its clients' requirements or project specifications, and likewise comply with the public health, safety, welfare, and environment protection as specified in several building codes, laws, regulations, both international and local. Building design has 3 stages. So once we complete these three stages, we call it building design. But if we don't complete, it's only building conceptual. So all building conceptual design is part of each stages. So the first stage is the conceptual phase, which belongs to the front-end engineering design of the plan. Initially, the project develops a program, or the client must list down all his requirements and project specifications. The architect then transforms and connects these requirements into spaces and meticulously relates them with each other through sketches and schematic drawings. This is an example of the matrix diagram. The rooms is correlate with each other. Then we proceed to the bubble diagram for the room layout. After this study, we can produce a schematic or conceptual plan for the building. In this stage, we only need at least 4 drawings or 4 pieces to the puzzle. First is the plan, section, and elevation, and the schedule of finishes. From this study, we can now extract a sufficient information for the overall size and general construction of the building, and a rough estimate of the building cost, construction cost, will be made for client's approval. So if rough cost estimate is less than or equal to client's requirements, or client's budget, we go to the next step. Stage 2. The architect or engineer now coordinates with various disciplines, with various consultants, such as engineering disciplines and specialists to work out in more detail and develop the raw design or rough drawing. The product of this stage will be initial construction drawings that will be used for outline specifications for the next final stage. So the plan, we will now have a detailed plan after talking to the consultants. So in this stage, we also have 4 drawings, which is very refined and very detailed already. The connection is very precise already. So another round and a more detailed cost estimation will be done to check again if the cost does not exceed the budget. This is meaning detailed cost estimate is less than or equal to the client's budget. Then we go to the next and final stage, the stage 3 detailed design stage, which is the engineering, procurement, or construction stage of the plan. It describes the production of construction drawings or working drawings, calculations, and specifications which are incorporated or used as contract documents between clients and contractor, which will become therefore as legal documents. So from the illustration, we have more pieces to connect or to solve. We will have 1 is the architectural drawings, 2nd is our calculations, then structural and civil drawings, 4th is the HVAC drawings, then lastly is the electrical and the plumbing and utility drawings. Then prior to completion of this stage, we need a final cost estimate which will be prepared, and if the cost cost will exceed the client's budget, the design will be revised again to achieve the necessary cost reduction. So the final piece to the puzzle is the final cost estimate, which should be less than or equal to, again, the client's budget. CPH role and involvement in Chiyoda's building design previously was only assisting Chiyoda Yokohama in stage 1 and stage 2 of the following projects during my time. First is the SEG in Sakhalin, Russia. Next is the QGX, RGX, AVG2, QPG project in Qatar. Sorry. Then the PNG project in Papua New Guinea and TMP project in Sarawak, Malaysia. The contract document phase, or stage 3, is normally awarded to EPC subcontractor, mainly for Qatar projects, while Chiyoda Yokohama or CGH with CPH is solely responsible for supplying all the necessary information, review, checking, approval, and control of subcontractor documents only. But now, CPH's role and involvement also include the third stage for Chiyoda's first full modular project, IGL in Australia. Now, from these experiences and exposures gained in assisting Chiyoda Yokohama in current and past projects will lead us in achieving Chiyoda's goal, that is to be self-sufficient in the future and have full confidence, independence in handling full-size projects. Now, building design consists of at least 4 members or discipline. First is the architect, which is my profession. So I am in charge of the conception of the idea, layout and form of the building, meaning plan, elevation, and section. The interior and exterior finishes, detail and specifications. And then lastly is to oversee the overall design of the building in reference to the utility function and aesthetic of the building. The second member is the structural or civil engineer, which specializes in the substructure and the superstructure of the building. Examples are foundations, columns and beam frame supports, and load-bearing walls, etc. Then the third member is the mechanical engineer, who specializes in the HVAC or heating, ventilation, air conditioning, and other installed machinery and equipment, such as crane, blast valve, laboratory, and kitchen equipments. Then also plumbing, utility, piping for toilet, shower, piping, sewage, and water supply. And utility piping such as compressed air and gases. He is also in charge of the fire protection and prevention of the building. And the last member of our building is the electrical engineer, who is in charge of the power, circuits, lighting, illumination, lightning protection, earthing, access control, and other equipment such as telecommunication, telephone, intercom, public announcement, general announcement, CCTV, and the firefighting and gas detection and alarm. Here is an illustration of our building group in Chiyoda, Philippines, and in CGH, Yokohama. This is an example of the building variation currently applied in IGL project. So for the content of my presentation, let me first define building. Building is an assemblage that is firmly attached to the ground and provides nearly total or nearly total shelter for machines, processing equipments, performance of human activities, storage of human possessions, and any combination of these. So building has many types according to the structure and function it serves in the plant. The first one is the stick build. This is the common type of building. These are conventional type. These are buildings with using conventional type or method of construction due to the abundant, skilled, and cheap labor at the building site. Second type is the blast-resistant building. These are normally occupied or manned buildings that are located in potential blast zone area. They are structurally designed to withstand blast overpressure to minimize injury to people and facilities from the hazard of accidental explosion in the plant. So here we have a picture in QPG project, FAR 13. This is normally a blast-resistant building using blast door and the blast bulb. Then one of the interesting building is the safe haven. This is mainly used as safe refuge, protection of personnel during emergency situations such as explosion or gas leak in the plant. During harsh or environmental conditions such as typhoon, earthquake, and tornadoes, and in rare occasions because of terrorist attack. These are usually blast or semi-blast resistant buildings, special equipment survival facilities such as forced entry or ballistic bulletproof blast resistant walls, doors, etc. Protected power supply, emergency generators, protected air supplies, satellite phone, radio-based communication, sustenance, meaning food and drink for 7 days, breathing apparatus, medical kits, CCTV camera, etc. Then now this building is the modular building, which is our current project in AGL. This project site where labor is very scarce or very expensive, buildings are constructed as full modules at fabrication yard in other countries where cheap skilled labor are readily available, such as Philippines, China, or Thailand. Then transported by ship and installed at site in Australia. It can be assembled in smaller units or for the entire building. Then the pre-engineered building or the PEB are pre-designed or prefabricated components that often rely on modular system. Equipment shelter refers to building that serve as protection, meaning walls and roof protection against the sun and bad weather of vital equipment. Example are SCG project. Then the shed. Shed is the most simple type of building. It provides protection roof only for against the bad. So example are transformer shed, vehicle shed, or car park facility, covered walkway, and waiting shed. Now buildings are segregated according to the zone or area activity. So normally we have three types: the non-plant or the non-process building. These are non-technical buildings that are not directly involved with the plant operation or the process. then the plant building or the process building. These are technical buildings that are directly involved with the plant process and have maybe sensitive information or data that we need to be restricted. Then in rare occasion, we have residential or miscellaneous facilities. These are permanent housing facility for the workers or staff. So residential is private, on the private activity. Non-plant buildings are the working or administrative area. Then the plant is the dangerous part of the area. This is an example of process technical buildings. Substation and instrument houses, equipment shelters, transformer shelter. Now for non-plant buildings, we have many types. Main gatehouse, administrative buildings, mosque, canteen, central control building, medical facility, fire station, laboratory, etc. Now as a conclusion or summary, based on my personal or observation and honest observation, architecture is the art and science of designing and constructing buildings, communities, and spaces for open areas. Hence, architecture always plays a vital role in the conceptual design, preliminary, detailed design, and until the actual execution and construction of the building. Then according to the first engineer, maybe in Roman time or Greek time, architecture should always be guided by the three principles. These are very universally accepted principles in all building design. First is the utilitas, meaning utility, use, and function of the building. Just check, we are perfect on this principle, always perfect. Then the third task is referring to durability, strength, and safety of the building. Also, we are perfect on this principle. Then the third one, Venus does, is the aesthetic beauty or form. Normally, since we are doing plant buildings, we don't normally focus on this side. So I guess we have room for improvement on this side. And I suggest maybe the reason why I suggest this one is maybe to level up or to make the standard higher and maybe change the game, because not all engineering is normally very simple, very direct. So we can maybe up the standard. So, and then also part of my summary is our CPH work history, showing the strength and weaknesses of our group in Manila. So beginning with SEG project, we only have around 3 members before, doing all stages of design, from stage 1 to stage 3. But now during QGX, RGX, and QPG and AKG project, the management decided to train the new or remaining members of building, around 2 members left, in CYO to experience and directly experience the flow of the design. But we were exposed only to review and checking of documents. Then for Barzan, B2K, and AEL project, we had experiences on plant buildings and non-plant buildings, but only in stage 1. And KNH also is likewise only review and checking of material, of drawings. PNG project is only stage 1. For non-plant residential, PNG project we have residential buildings, but only stage 1. The TFP project, non-plant, and review checking of mechanical drawings and electrical. Then our current project, the IGL in Australia, we have, I think, completed all stages, including stage 3. And also the members are complete, and now we have many members now. So our strength maybe is in stage 1, and red items are our weaknesses. So our vision, my final CPH way forward. In line with CPH goal and management plan of increasing man-hour transfer ratio to CPH, we recommend the following. Building concept must be able to originate from CPH. My understanding is we always receive from Chiyoda, a building group. We don't directly coordinate with, example is electrical group or instrument group, which is our direct client. So we always receive information from our building group in CGH. Then detailed design for all types of building and phase must also be able to perform in CPH, because in some items we lack experiences as shown in the previous slide. So CPH requests CGH support by conducting training program, TTP, such as building planning, building structural design, especially on the blast resistant building. We are very weak on this part now. And then also in building electrical design, because we have young members, but very good attitude and very good potentials. So we need them to be trained, especially the young architects and young mechanical engineers and electrical engineers. Then currently, coordination is directly between Chiyoda Yokohama only and CPH building. In the future, we hope to do internal coordination among our departments, especially electrical instrument to civil and building. So thank you and very much for listening, and any questions?
All right, thank you very much for your From your presentation, may we understand CPH will take part of all building conceptual design soon?
Maybe assist also, and not totally take over, but because we need to have direct contact with the clients. That's the most important part. But since client is in Japan, So we will still play our role as assisting Chiyoda Yokohama, but we'd like to maintain the standard.
Okay, thank you very much. Okay, anybody have some comments or question for the building conceptual design? Right.
Again. As a philosophy to develop work sharing with shipbuilding in the beginning, especially around 2000. In Yokohama engineering discipline, we reduced so many people, especially building, because 2000 or 2004 is worst condition that Chiyoda. So at that time, maybe only limited people stay in Chiyoda, the civil department handling for building. And at that time, idea is most of building or activity should be shifted. The CPH. It's an original concept of that. And now, right now, Chiyoda also enforce a little bit for the building people, but the original concept is that. So, but it means that Chiyoda global headquarters have an implementation. First, how to plan for that, especially looking for the client specification and also coordinate the requirements of the principles. But actual work, intention since 2000 is what you want, right? And another point is, of course, at the end of closing, I'm also explaining coordination and CPH, right, for electric instrument. It's correct. But the point is sometimes we need some allowance for example, as the electric space is not finite. So how to put on another extra engineering development space is sometimes for the Chiyoda global headquarters law. So you can, or you may coordinate preliminary, but most of the case at this moment or still some future, according to budget and security point of view, decision still maybe Yokohama, but you can coordinate, right?
Yes, sir.
What is your recommendation?
In coordination.
Among CPH.
Sorry, sir.
The CPH, inside of CPH,
Coordination.
among discipline, right? As you pointed out. But decision, most of the case, is finally come from Chiyoda global headquarters. The reason is sometimes we need some allowance for the space of control building, because sometimes it is not finally defined how many control panels for electric will require. Right?
Yes. Now, I think the electrical group is going to CGH building and then they will pass. Example is the plan, the electrical layout plan. We always receive the plans from the building group. We don't receive it directly from the electrical CGH. So, just suggestion that we need to experience that side.
Yes,
Not necessarily to.
Yes.
Yes, sir.
Thank you very much.
Okay, thank you.
Thank you very much, Sakaguchi-san. Okay, any other comments? Does anybody have some comments or suggestion or any supportive explanation from the Chiyoda Yokohama civil manager? Any suggestion? Nothing?
Yes, sir.
Yeah. Actually, we know the first draft of your presentation, so
Yes, sir.
thank you very much. It's very improved. It's very improved. And point is, through our training program, then let's see. So, yeah, this is the point. So you know the strong point and weak point. Then still we have a lot of field project, so we need design, especially room layout. But as you know, client is in Japan,
Yes, sir.
CZH. So what do you think? Can you work and communicate with client in Japan?
One solution maybe is maybe to assign one of our members, architects in Japan, to maybe experience to directly communicating with the clients, because through the phone it's very difficult experience to communicate with the clients, and also it's the one-on-one conversation is always better. So you get the direct point message of the client, and also it's more professional than using the phone. So maybe it's to assign a building architect or young architect to experience that and help CGH. Yes, sir. But maybe difficult if we do it communicating via phone or.
Thank you.
Okay, thank you very much. Any other comments? Nothing? Okay, thank you very much for your explanation. Thank you very much. Yeah. Okay, let's move to the next presentation. This is the final one. Presentation number 25.
Thank you po.
Implementation of hardware, software inventory, and software metering system in CPH. Presenter is Mr. Delvin Jose Jr. Please go ahead.
So, good afternoon, ladies and gentlemen. My name is Delvin Jose from Corporate IT Service Department, and I'm here to present the implementation of software, hardware inventory, software metering, and data loss preventions at CPH. Now, for the outline of my outline of my presentation, I'll be discussing the introduction, the objective, the concept of hardware and software metering, hardware inventory, data loss prevention, how to achieve the target objective, the benefits of these applications, and the future plan of CPH. So why did we introduce this system? Since the beginning, CPH implement hardware and software inventory and software metering using manual collection. And it takes a long time for corporate IT service department, project IT service, to generate reports for CPH management. CPH is also looking to improve the data security, for us to eliminate disclosure of confidential information owned by CPH. Solution to the problem. In order to solve this problem, we started to test some of applications. Among the applications that we tested are as follows: Total System Analyzer for hardware and software inventory, software metering for Open IT, and McAfee DLP for data loss prevention, securing confidential information. Let me give you a little bit background for this software. The Total System Analyzer is basically checking what are the computer installed on your computer, on your PC, what models, what serial number, how much disk space remaining on your computer, what serial number, and of course, how much available RAM memory are installed. For software inventory, basically, what software installed, right? How many licenses are there? Which computer has compliance in terms of software? Something like that. For the Open IT software metering, basically it checks whether you properly utilize your computer, your applications. For example, for McAfee DLP, it literally checks and prevents user from leaking confidential information owned by CPH. For the objective, implement a hardware and software inventory as well as software metering that can generate relevant and timely report with minimum manual collections of data and allow effective management for hardware and software as well as software metering in CPH. Implement a solution software that protects from risk from associated with unauthorized transfer of data from within or outside CPH. So that's our objective. Now, for the concept of this software, basically all software that I mentioned is using the so-called client agents. Agents are software or IT software that's responsible for checking your computer, monitoring your computer, listening your computer, and basically implementing the policy mandated by the IT security manager or the IT administrator. So those informations gathered by these so-called agents are then reported to a so-called listener server. Some applications call it core server. And those informations are now pushed to a so-called database server. In our case, in CPH, this McAfee DLP, OpenID, and Total System Analyzer uses Microsoft SQL Server as a database platform. So those informations are now collected, and out of that, we can generate a simple and understandable format using this compiled information. How to achieve the target objective? For hardware and software inventory under Total System Analyzer, implement a system that will generate a report for hardware specification, software installed, readily confirms the use of available PC. For example, in my slide here, we can see whether the PC is in use or not, whether the computer is continuously running 24 hours. So it is really a good help for corporate IT, in our case, as a reference for pulling out of PC. For example, as we notice that it's almost a month and this computer is not running and this PC is still on the operation, corporate IT will pull out those PCs and allocate it to another department. So that's one good source of information. Another good function of this Total System Analyzer is that it readily confirms the warning signs, whether it's a low of RAM memory, low in disk space, and the processor. For example, in my example, this IT152 only occupies as much as 70% of its CPU utilization, and the memory only has 40%. So it means it's okay. But if we receive complaints coming from different persons, from different departments, saying that the computer is very slow, we can use this application to check. Oh, this computer is already 100% utilization of its memory or its processor. I think it's about time to replace that computer, isn't it? For our engineers to maximize their computer. Okay, another function of this application, it monitors your computer's activity. It's like having a surveillance camera on your computer. It actually screenshots your computer every 5 minutes to monitor what are you really doing on your computer. So this is one function of this. Plus, of course, the active process and the window title running on your computer. It literally checks every 5 minutes. Another function is this software usage chart. So we can literally check what are the applications running on your computer. how much percentage. No? For example, here, as we check, most of it are Microsoft product, Lotus Notes, and antivirus software. Now for the open IT, how to achieve the target objective, software metering creates a system that readily confirms the usage of a particular software. For example, AutoCAD. Whether it's a purchase license or lease license, license can be based on actual usage strength in terms of CPU input and output, keyboard activity on that applications, and mouse movement. So this is how smart this OpenIT is, this OpenIT application. No? Software metering measures the usage of actual usage, providing important information, whether deciding if the license should be allocated by individual or to be considered as common use. So this is just an example of what we have during our POC. So we ran this application for 5 days, and we noticed that, for example, in this server CEC 39, we have a max available license of 27. This is actually AutoCAD. The max in use by our employees is around 10, 16, 14, 1, of course, Sunday 0, and 15. So here we can check whether they're using our AutoCAD or not, right? For certain application. So if we're going to put it in a management point of view on how to save a cost, for example, 18 unutilized license. Each license costs us 250,000 pesos. If you convert it into yen, that's 500 mostly, no? 500,000 yen times the unutilized license. That is 4.5 million pesos waste. Now, this software help us to check. So it's a good application on our side that we make sure that our license is properly utilized. That's the main idea of this software metering. For the MAPAPI DLP, data loss prevention, we implement a system that safeguards our sensitive information, of course by deploying policies. Example of these policies are email protections. If, for example, a certain person accidentally or intentionally have a confidential information owned by accounting or, for example, admin, he cannot attach this important information, confidential information using email. It will prevent him for doing so. He cannot copy confidential information to USB. He cannot even use print screen function and also the copy and paste function. He cannot. And if in case this person implement this kind of procedures, this system will report to an IT security manager. And from there, we will have a solid evidence that there is a person who is trying to do this kind of actions. So this is just an example of the DLP chart. So we basically check whether our computer is compliant, our employees are doing this or that. So these are sample report. Now, what are the benefits of these three applications that I mentioned? For hardware and software inventory, report can be generated automatically based on hardware specifications, the actual conditions of the software installed. For software metering, license forecasting can be made more accurately. This will enable CPH to maximize the use of software under network licensing terms. For data loss prevention, it protects CPH from leaking confidential information. Now, for the future plan of CPH, full implementation of hardware and software inventory and software metering at the end of 2012. Review the result of first quarter of 2013 and fine-tune the set policies and according to the trend of hardware and software activities, software metering, and data loss prevention. Integration of hardware inventory and software inventory to CPH-CNS. This is similar to ERP of Chiyoda. So this is our plan, future plan. Thank you very much.